So to back us up and to kind of just get us going on all this stuff, we see hydrocarbon markers throughout the mantle petrology, serpentinite steatization, and mud volcanism and the reservoirs we drill in with the UDH model. So these anomalies that we found in the mantle petrology are what we see in serpentinites and what continuously happens in talc and steatization. We keep seeing these data points, and diamondoids are also consistent. So the mantle petrology to the surface rocks that we drill into and get recovery out of have a marker, have several markers. We're talking about hydrocarbon markers. Now we're talking about diamondoids specifically in this process. What do we see in the mantle petrology? What kind of diamondoids do we see in serpentinization, steatization? Ultimately getting to a very interesting concept, the subcritical supercritical boundary. That's the true kitchen. This is where hydrocarbon generation on this planet is just pumping naturally. It's building alkane chains like crazy, and we'll get into that reason why and how we see it in the data and how Stan and Monty and the MagmaChem team has put this story together. Stan?
Okay. I can't compete with that one.
How did it all start? The history. Monty was kind of hinting towards that. Let's start there.
Yeah, well, let's go back to what Monty just said, which is we're now dogma-chem on this subject, which means no diamonds, no oil. Every oil has diamonds in it. More specifically, hydrogen cage diamondoids. And as we'll get into it, we've developed a model for how you make the diamondoids turn out to be an interface between various kerogen polymerizations that lead to oil. And an important ingredient of that is hydrogen and also chlorine, which for those that have been following this story happens on Mars big time. And we are predicting that diamondoids will be found on Mars as well. But they don't quite have those analytical capabilities on the Curiosity yet.
Let's get back to this planet now.
Oh, quiet.
But I like it. We have a Mars presentation that's out there that shares all that information. But yeah.
So diamondoids have been around for a while. They've been found in crude oil, and as it turns out, all crude oils have them. And they were initially found by some Czech geologists that were working with Czech oils back in the early 1930s. I think it says that somewhere.
Yeah, it says something about 1933.
Right, 1933. Yeah. And then they laid around as adamantane for a while. That was the first one to be identified, and it's still the one that's most important too and most common in oil. But then Chevron got into the game, and in particular they got Jeremy Dahl and who's the other Chevron? Dr. Carlson. And Richard Carlson, and we were very fortunate to have a diamondoid short course given it to us by two of the originators, so it's pretty neat.
Wow. Now, you see this in the data, you're seeing this in the literature, you're going there, to you, you're saying, wait a minute, that is a high temperature, high pressure situation, there's something going on here, and that's what sparked your initial curiosity, wasn't it?
Well, yeah, it was the idea that that's the common sense idea that's been out in the popular literature forever, which is that, well, ever since Superman, squeezing a piece of coal and turning it at high pressure into diamond. So, that was the vision that I had of these things. And so I said, wait a minute, there's some kind of high pressure, high temperature game going on here. And as it turns out, all the experimental science all says that. But then you can ask the question, what is it that distinguishes a diamondoid from a diamond? And it's basically hydrogen. So when you shine your ring like this, somebody's put a little bit of oil in there and it's bonded a bunch of hydrogen atoms to the outside of that diamond and shining it up. So they're kind of putting an oil / hydrogen cage around the diamond. So, and this is the diamond structure itself, which has hydrogens built around it. They're not showing those. But now, our experience with diamondoids came from studying diamond quartz.